I mentioned initial value problem and boundary value problems before, and now I add the slides to introduce to you. So after you get the mesh and you get the initial condition data, what is the simulation about? It is what we call time integration, is to have the data of the atmospheric state and the land surface, which is three-dimensional data, and land surface actually has some model have 4 layers of soil, and then the soil moisture is actually quite important. And if the model only have the surface layer, then along the simulation, it will not be accurate enough in how much water will be evaporated from the soil. So some land surface model have 4 layers of soil and have the data of soil moisture in the second layer, in the third layer, and the deepest layer. So along time integration, the land surface model will simulate the change of soil moisture and the amount of moisture evaporated, something like that. So if you are having a global mesh, then you only need initial condition data. And then the simulation will simulate the evolution of the atmospheric states and the surface land states a long time. Say your simulation runs for 5.5 days, then it is the computation that you are waiting for after you submit the job. And if you do not use a global simulation, you specify lateral boundary, then the problem is called boundary value problem. And in the simulation, in addition to the initial condition data, you also need lateral boundary condition data for along the period of time you do the simulation. And that data is for supplying the data to such lateral boundary, and then the simulation is only carried out inside this limited area, relying on the data you feed in. Okay, I think in this project we will do a global simulation.